Can we start? Can we start the class? Actually, I cannot hear someone. Hello? Hello? Okay, we start the class. In our previous class, we discussed about random variable and distribution function of a random variable. A random variable occur as we know that sometime in many experiment we are interested in the number associated with the outcomes instead of their individual outcomes. That is, we associate a real number with every outcome and we are interested that real number, and we said that a mapping S x from S to R, S is the sample space or event space, is called a random variable if the inverse image under X of all the semi-closed interval of the form minus infinity to X are the event belongs to the sigma field delta. That is, under the inverse image X inverse, we searching for this event W belongs to S such that XW lies between minus infinity to X, that belongs to delta sigma field. If this condition hold, then we can say that the function X S to R for a random experiment is a random variable. And to understand the random variable, we discuss several examples. Next, we discuss about distribution function of a random variable. We told that a function capital F R to R, real number to real number, we define as fx is equal to probability of minus infinity to x. That is, probability of that event W belongs to S such that minus infinity x of W lies between minus infinity to x. If we consider a random experiment, then we have this event space S. On S, we define a real valued function capital X S to R, and we find the inverse image capital X inverse minus infinity to X, and search for that event S belongs to W belongs to capital S such that XW lies between minus infinity to X. This was the random variable. Then we define probability distribution function. By probability distribution function, we actually find the probability of that particular event W such that W xw belongs to minus infinity to x. These are the relation between random variable and distribution function. And we talk about several examples on distribution function. Now, today we give the definition of expectation. Okay. If x is a discrete random variable, what is discrete random variable? If the range or spectrum of a random variable is discrete, then we call that the random variable is discrete random variable. Okay. Here says that if x is a discrete random variable, assuming values x1, x2, dot dot xn with probabilities p1, p2, dot dot pn, then their expectation is denoted by E capital X and defined by summation of xi pi. If small f(x) be the probability mass function of the random variable x, then expectation of x is defined as sum of xi f of xi. And for continuous random variable, that is the spectrum is continuous. And if x is a continuous random variable and small fx be its probability density function, then the expectation of the random variable is defined as ex is equal to integration minus infinity to plus infinity x fx dx if the limit exists. Therefore, for discrete random variable, expectation is sum of xi f of xi, and for continuous random variable, expectation is equal to integration minus infinity to infinity x fx dx. This is the expectation of a random variable. Similar to the random variable, here expectation has also similar properties. If x and y are two random variables, then expectation of x plus minus y is equal to expectation of x plus minus expectation of y. The second property says that if x and y are linearly independent variable, then expectation of xy is equal to expectation of y. Expectation of a constant is equal to that constant, and expectation of scalar multiple of a random variable is equal to that scalar multiple into expectation of that variable. And number 5 is the Cauchy-Schwarz inequality. It says that expectation of x by whole square less or equal to expectation of x square. And Cauchy-Schwarz inequality says that expectation of xy square less or equal to expectation of x square into expectation of y square. This is the Cauchy-Schwarz inequality. These are the property we did not require their proof. Can you hear me? Hello? Is it clear what is expectation? Hello? Okay. Eh, Is my voice is clear? Actually, yesterday someone says that the sound is low. Okay. Actually, these are all mathematical terms, so it is quite difficult to understand first time. Okay, now we define variance. Let x be a random variable. Then we denoted variance of the random variable as var x, VARX, and define as var x is equal to expectation of x square minus expectation of x the whole square. That is expectation of the random variable x square minus expectation of that random variable x the whole square. For discrete random variable, var x is defined as sum of xi the whole square minus into pi minus sum of xi pi the whole square. And for continuous random variable, var x, that is variance of the random variable x, is defined as minus infinity to infinity x square fx dx. Here small fx is density function minus infinity to x fx dx by whole square. These are definition of var x for discrete random variable and for continuous random variable. In our previous class, we discussed probability distribution function. Today, we will discuss some particular distribution function. In our previous class, we discussed some example and show that how we calculate the distribution function. Now, binomial distribution function. The binomial distribution of a random variable x is defined as the probability mass function fx given by fx is equal to ncx p to the power x q to the power n minus x, where x belongs to 0, 1, 2, dot, dot, n, that belongs to the natural number, and p lies between 0 and 1, and p plus q is equal to 1. Here we consider p as success and q as failure. P as the probability of success and q as the probability of failure, and we know that the probability of any event lies between 0 and 1. Therefore, p plus q must be 1. Binomial distribution similarly expressed as BNP, where n and p are parameters of the binomial distribution. Actually, n is the number of how many times the distribution is repeated, and p is the probability of success. Here the random variable has only two outcomes: success or failure. That is success and 1 minus success. Now we find that expectation of x, that is the mean of the binomial distribution, and the variance of the binomial distribution. For mean, we calculate expectation of x, and we know that expectation here, binomial distribution is a discrete random variable, as it takes values x1 x2 dot dot to xn. Therefore, it is discrete random variable. That is x1 x2 xn is the spectrum of the distribution function x. So distribution random variable x, as this is discrete, therefore the random variable is discrete. And for discrete random variable, we know that expectation of x is defined as sum of xi f of xi. Here f of xi is ncxi p to the power xi into q to the power n minus xi. For simplicity, we replace xi by small I. Therefore, e of x is equal to sum that runs from I is equal to 0 to n, I into nci p to the power I into q to the power n minus I. Here q is equal to 1 minus p. And nci means factorial n by factorial I into n minus I. This is the third line. If we take n and p outside the summation, then power of p becomes p to the power I minus 1, and I and factorial I, 1 I must be cancelled. This gives the line 4. One n is coming from the summation, therefore factorial n becomes n minus 1, a factorial. Therefore, in now the fifth line comes from that uh, this is the n minus 1 c I minus 1. Here we replace I minus 1 equal to j, and p to the power j, because there was p to the power I minus 1, and q1 minus p to the power n minus 1 minus j. Actually, this is printing mistake. This will be n minus 1 minus j, not I. And from the binomial expansion, that is a plus x whole to the power n is equal to nc0 x to the power a to the power n x to the power 0 plus nc1 x to the power n a to the power n minus 1 x to the power 1. Applying this expanding, we get the fifth line number 6. Here a is p and x is 1 minus p. Therefore, p plus a plus x whole to the power n minus 1. Here p plus 1 minus p whole to the power n minus 1. And this is equal to 1. Therefore, expectation of x is equal to np. Actually, it is difficult to understand by hearing like this. You try yourself. If you cannot find how this equation came from, then you can email me or can tell about the next class. Now we want to find what is the variance of the random variable x. We know that variance of x, that is vertex, is equal to e of x square minus e of x the whole square. For this, first we find expectation of x into x minus 1. Exactly same calculation is here. Just previous one, x, where we find expectation of x. In the finding of expectation of x, we only take out np from the summation sign. Here the difference is we take off out n into n minus 1 into p square, and the remaining equation are same, and we get that expectation of x into x minus 1 is equal to n into n minus 1 into p square. And putting the value of this expression and expectation of x, we can find that var of x is equal to npq. Only 2 or 3 line calculation required. Therefore, we find that if a random variable x satisfied binomial distribution, then its probability mass function must satisfy f of x is equal to ncx p to the power x q to the power n minus x. This is the probability mass function. If the random variable of a random variable x satisfies this equation, therefore you can say that this is a binomial distribution. And we find that the mean of the binomial distribution is np and variance of the binomial distribution is npq. To understand this, we go through some example. The first one is two paired die are rolled 100 times. Find the probability of getting at least one a double six. Therefore, what is the event? Random event. Here the random event is two dice are thrown 100 times. Here the random event is two dice are thrown. This is the random event. And we find the probability of getting at least one double six. Therefore, if we consider x denote the number of double six, then clearly x is a binomial distribution because it has only two outcomes. Either either the either the outcomes has double six or it has not double six. And as the dice are thrown 100 times, we can here n is equal to hundreds for the binomial distribution. And p is the probability of getting a double six. This is p. And we note that when two dice are thrown, then the sample space contain 36 element, 6 into 6 element, that is 36 element, and there is only one outcome, that is 6 6, that is double six. Therefore, getting a double six is probably its probability is 1 by 36. If we consider that x denote the number of times a double six is obtained, then the random variable is a binomial distribution with parameter n is equal to 100 and p is equal to 1 by 36. Okay, here we have to find that the probability of getting at least once double six, that is x greater equal to 1, here x is the number of times a double six is obtained, and we have to find at least one double six. It may be 2, 3, or 36. Therefore, p x greater equal to 1 is equal to, we can, it is easy to find that the complement event space. Therefore, the p of x greater equal to 1 can be replaced as 1 minus p of x by x is equal to 0. As x satisfies x is a binomial distribution, therefore probability of x is equal to 0 can be found by its probability mass function, and we know that the probability mass function is n c x to the power p into 1 minus p to the power n minus x. Putting the value n is equal to 100 and x is equal to 0, we can evaluate that p probability of x greater equal to 1 equal to 1 minus 35 by 36 to the power 100. This is a simple calculation. Actually, it is main, we have to find that which distribution the random variable satisfies. Okay, we go through second example. The second example says that what is the probability of obtaining multiple of 3 twice in a thrown of 6 dice? Our main task is what is the random experiment, and the corresponding random variable satisfies which distribution function. If we find these two, then we can solve this and solve this question. Here the question says that what is the probability of obtaining multiple of 3 twice in a thrown of 6 dice? Here the random variable is throwing a die, and this happened 6 times. Therefore, n is equal to 6, and and the event is getting multiple of 3 twice. When a die is thrown, then we know that its sample space contain 6 elements: 1, 2, 3, 4, 5, and 6. If we consider the event that x is the multiple of 3, then the event contain only 2 elements, 3 and 6. Therefore, probability of getting a multiple of 3 is equal to 3 by 6, that is, sorry, 2 by 6, that is 1/3. Okay, therefore this random variable x satisfies binomial distribution having n is equal to 6 and x is equal to 2, because you have to find the multiplicity of 3 twice. By binomial law, the required probability is ncx p to the power x q to the power n minus x. Put the value n is equal to 6 and x is equal to 2, then we can find the probability of getting multiple of 3 twice. Is it clear? There are another example. These are your home tasks. Several examples are here. Now we discuss about Poisson distribution. This is also a discrete random variable. The difference between Poisson distribution and binomial distribution. In binomial distribution, the random variable x finite number elements, that is x1, x2, to n. But a Poisson distribution function can take enumerable number of can take from a set, from a enumerable set. Enumerable set means either the set is finite or countably infinite. It may be finite, that is x1, x2, to xn, or countably infinite, that is this number can be count, but you have to count infinitely, up to infinity. Okay, the Poisson is discrete random variable x having enumerable set 0, 1 to করে as a spectrum, that is range, is said to have Poisson distribution with parameter mu which greater than 0 if its probability mass function satisfy the equation fx is equal to x to the power minus mu, sorry, fx is equal to e to the power minus mu to the power x by factorial x, where x is equal to 0, 1 to up to infinity equal to 0 square. Therefore, a discrete random variable x having enumerable set 0, 1 to infinity as a range set is said to have a Poisson distribution with parameter mu if the probability mass function PMF is given by fx is equal to e to the power minus mu to the power x by factorial x, for x is equal to 0, 1 to 4 and equal to 0 elsewhere. Now we have to find what is the mean of the Poisson distribution and variance of the Poisson distribution. For means, we have to find expectation of x, and we know that the Poisson distribution is a discrete random variable. Therefore, expectation of x is equal to, we know that expected for discrete random variable, we know that expectation of x is equal to x summation xi f of xi. To avoid mathematical complexity, we replace xi by I, and we know that f of x is equal to e to the power minus mu e to the power x by factorial x. Therefore, expectation of x is equal to the second line I e to the power minus mu into mu to the power x I by factorial I. We come out mu and e to the power minus mu from summation sign. Therefore, power of mu become I minus 1 and one I is cancelled. Therefore, factorial I become I minus 1 factorial. And the remaining term is the expression of e to the power x. E to the power, we know that e to the power by n runs from 0 to infinity. Here n is replaced by j. Therefore, this is summation mu to the power j by factorial j. J runs from 0 to infinity is equal to e to the power mu. Therefore, mean of a Poisson distribution is equal to mu. Similar of binomial distribution, we also found that to find the variance of x, we first find expectation of x into x minus 1, and this this calculation is similar, and we know that this is equal to mu square, and var x is equal to, it also is equal to mu. A 2 or 3 line calculation. Var x is equal to, we know that var x is equal to expectation of x square minus expectation of x whole square, and it will be also mu. Therefore, for Poisson distribution x, the expectation of the Poisson distribution x is mu and its variance also mu. We give one example to understand what is Poisson distribution. Example 1 says that a hospital switchboard received on average 4 emergency call in a 5-minute interval. A hospital switchboard received on average 4 emergency call in a 5-minute interval. What is the probability that here are almost 2 emergency call in a 5-minute interval? That is, what is the probability that maximum 2 emergency call in a 5-minute interval? And exactly the second one is exactly 3 emergency call in a 5-minute interval. Our first case is which distribution function is satisfied by the random variable. That is, which is the random experiment here. Let x denote the number of calls received in a 5-minute interval. Then we can find that x satisfied Poisson distribution. In Poisson distribution, mu that greater than 0 is the average number of probability of that particular event. Here x denote the number of calls received in a 5-minute interval. Therefore, x satisfies Poisson distribution while mu equal to 4. we have to find that the probability of at most two emergency call is received in a 5-minute interval. That is probability of x less or equal to 2. You have to find the probability. Probability of x less or equal to 2 means probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2, because there is no other point, as the random variable x contain only 3 points between minus infinity to 2. The points are 0, 1 and 2. Therefore we have to find the probability of x less or equal to 2. We have to find the probability of x at 0 plus probability of x at 1 and probability of x at 2. And we know that in our previous class the probability came from the distribution function, and putting the value x is equal to 0 in the distribution function, or that is probability mass function, that is in fx, then we can find the value of the probability of x is equal to small x, where small x is equal to 0. Therefore probability of x is equal to 0 means e to the power minus mu, here mu is equal to 4, mu to the power x, here x is equal to 0 by factorial x, where x is equal to 0. Therefore probability of x is equal to 0 is equal to e to the power minus 4 to the power 0 by factorial 0. Similarly, probability of x is equal to 1 can be derived, and probability of x is equal to 2 can be derived as x to the power e to the power minus 4 to the power 2 by factorial 2, and this is equal to 13 to e to the power minus 4. This is the probability of at most 4 emergency calls are received in a 5-minute interval. Now the second question was exactly 3 emergency call is received in a 5-minute interval. That is we have to find the probability of x is equal to 3. And we can find this probability by putting x is equal to 3 and mu is equal to 4 in the probability mass function, and this result came. There is another example. The number of emergency admission each day to a hospital is found to have a Poisson distribution with parameter 2. Parameter 2 means the Poisson variable uh, parameter mu is equal to 2. The number of emergency admission each day to a hospital is found to have a Poisson distribution with parameter 2. The question is evaluate the probability that on a particular day there will be no emergency admission. That is, we have to find probability of x is equal to 0. That is, there is no admission. And the second one is at the beginning of one day the hospital has 5 beds available for emergency. It is a given condition. At the beginning of one day the hospital has 5 beds available for emergency. Calculate the probability that this will be an efficient number. Calculate the probability that this will be an efficient number for the day. That's mean we have to find the probability of x greater equal to 6. If x greater equal to 6, therefore the uh, emergency capacity of this hospital will be exceed. Okay, let the probability for I admission on a day p of probability of x is equal to I. We know that probability mass function of a Poisson distribution satisfied e to the power minus mu to the power x by factorial x. Here the average admission is 2, therefore mu equal to 2. It was given, and x is equal to I. Therefore, probability of x is equal to I is equal to e to the power minus 2 to the power I by factorial I. For the first question says that evaluate the probability that one particular day there will be no emergency admission. That is probability of x is equal to 0. If we put x is equal to 0 in the probability mass function fx, then we find that probability x is equal to 0 is equal to e to the power minus 2. And the second question was at the if the hospital has 5 bed available for emergency, what is the probability that this number will be an efficient for a particular day? That is, we have to find that probability of x less or equal to 6. That means we have to find that probability of x greater than 5. This is the complement of probability of x greater equal to 6. And probability of x greater than 5 means 1 minus probability of x less or equal to 5. To find this, we have to find 1 minus probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 5. And this came from the probability mass distribution function of the random variable x. After calculation, you will find that the answer is this, approximately 0.011166. Here also several examples to understand what is Poisson distribution. For such question, actually we have to find the random experiment. Then we have to find what is the random variable, and lastly we have to find which distribution function is satisfied by that random variable. If the random variable has only two outcomes, say success and failure, and the random variable take only finite number of real numbers, then we find that x must satisfy binomial distribution. And we said that the random variable satisfy Poisson distribution if it take values from an enumerable set, that is it is either finite or countably infinite number of points in their spectrum or range. and it has a average. It has the average success, that is mu. You have to find what is mu for Poisson distribution. These are the example of Poisson distribution. Now we discuss about normal distribution. A random variable with the normal distribution of a random variable x with parameter mu and sigma, where sigma greater than 0, is defined by the probability density function fx given by fx is equal to 1 by root over 2 pi into sigma into e to the power minus of x minus mu the whole square by 2 sigma square, where x lies between minus infinity to plus infinity. A random variable with the above probability function is called a normal variable. The fact that x follows normal distribution with parameter mu and sigma is expressed symbolically as n mu sigma square. This is the notation of a normal distribution, n mu sigma square. In particular, if mu is equal to 1 and sigma square is equal to, sorry, mu is equal to 0 and sigma square is equal to 1, then we call that this is standard normal distribution. In a normal distribution, if mu is equal to 0 and sigma is equal to 1, then we say that the normal distribution is standard normal distribution. Recently, we will find that the mean of a normal distribution is equal to mu and variance of a normal distribution is sigma square. That's why it is denoted by n mu sigma square. And a normal distribution, normal variable x must satisfy probability density function fx is equal to 1 by root over 2 pi sigma e to the power minus x minus mu the whole square by 2 mu 2 sigma square. This is the expression of probability mass probability density function of a normal distribution. Now we find the expectation or mean of a normal distribution. The normal distribution is a continuous random variable. And we know that for a continuous random variable, the expectation ex is defined as integration minus infinity to plus infinity xi f of xi. Sorry, I mean, as x and f of x dx. If the limit exists, this was the expression of expectation of a continuous random variable. Here fx is given for a random normal distribution as 1 by root over 2 by sigma into e to the power minus of x minus mu the whole square by 2 sigma squared dx. If we replace x minus mu by root 2 sigma by t, then we find that as x tends to minus infinity, then t also tends to minus infinity, and as t tends to infinity, as x tends to infinity, then t also tends to infinity. After putting this, the expectation of x can be expressed by line 3. After few line calculation, we find that we can find that expectation of x is equal to mu. Here two result is will be need. One the result one is integration minus infinity to infinity to the power minus t square dt is equal to root 5. And for a odd function minus infinity to infinity, the integration of that odd function is equal to 0. With these two results, we can find that expectation of x is equal to mu. Similarly, we can find expectation of x square as root 5 by 2. And we know that variance of x is equal to e of x square minus e of x the whole square. And that is equal to sigma square. Therefore, for a normal distribution in mu sigma, the expectation that is mean of the normal distribution is mu, and variance of the normal distribution is sigma square. We know that in a normal distribution, when mu is equal to 0 and sigma is equal to 1, then we call that normal distribution as the standard normal distribution. Now we discuss about the normal probability table. A table showing the probability that z is less than or equal to a particular value of z is known as probability table. It is actually probability of that event w that belongs to S, the sample space, such that xw lies between minus infinity to x. Here x is z, that therefore the probability of the event that lies between minus infinity to z. And this comes from the probability for distribution for discrete random variable. This came from probability in mass function fx, and for continuous random variable it came from probability density function fx, here denoted by phi x. As we consider the normal standard normal distribution, therefore phi x is equal to 1 by root over 2 pi minus infinity to z to the power minus t square by 2 dt. This came from the probability density function of the standard normal distribution. And we know that for a probability of a less equal to x less equal to b is equal to f of b minus f of x, f of a, where f is the probability distribution function. Sorry, f is the distribution function or convoluted distribution function. Here f is capital phi. Here, here is an example. If x is a normal distribution with mean 30 and variance 25, then we have to find that probability of x get equal to 45, probability of probability uh, where x lies between 26 and 40, and probability of mod of x minus 30 greater than 5. We know that we know only norm probability table for the standard normal distribution. For standard normal distribution, we know the probability table. Therefore, to solve this, we have to go first the standard normal distribution. Here, here the normal distribution is n 3025, which is x. If we consider z equal to x minus 30 by 5, that is x minus mu by sigma, then z will be the standard normal distribution, and we can find the value from the distribution table, probability table of the normal distribution. Now we have to find probability of x zeta equal to 45. To normalized, that is to find the normal standard normal distribution, we first transform x to z by z equal to x minus 30 by 5, then z will be standard normal distribution. This is why probability of x greater equal to 5 is equal to probability of x minus 30 by 5, which is equal to greater equal to 45 by 30, 45 minus 30 by 5, and x minus 30 by 5, this is a standard normal distribution, and therefore we can find the probability. Therefore probability of x greater equal to 45 is equal to probability of z greater equal to 3, and probability of z greater equal to 3 means 1 minus probability of z less than 3. This is the complement of the event z greater equal to 3, which is equal to 1 minus probability of z less or equal to 3, as probability of z equal to 3 is 0. This is a known result. Probability of x is equal to small x is equal to 0. Therefore probability of x greater equal to 45 is equal to 1 minus 53, and from the we have no distribution probability table for normal distribution, but uh, we can find that probability of um, 3 for normal distribution, that is phi 3 is equal to 0.99865. Therefore probability of x greater equal to 45 is equal to this one, 0.00135. These are all rigorous calculation. There is no question of understand. Similarly, for probability where when the distribution function lies between 26 and 40, first we um, convert the normal distribution x to z, the standard normal distribution. Then from the probability table of standard normal distribution, we find the probability of some a, that is phi of a, and this give you a result. This is the third problem. The another example, and these are the exercise. In our next class, we talked about measure of central tendency. That is, what is mean, mode, median. In our syllabus, we have only three distribution. Number one is binomial distribution. The second one is Poisson distribution, and the third one is normal distribution. Okay. আজ এ পর্যন্তই। পরের দিন আমরা সেন্ট্রাল টেন্ডেন্সি নিয়ে কথা বলবো। হ্যালো, হ্যালো, anyone can hear me?
Yes, sir.
ওকে, তোমরা তোমরা যে এক্সাম্পল গুলো ছেড়ে দিলাম সেগুলো করে নিও, আর সেগুলো দেখে নিও। ওকে, আমি বুঝতে পারছি এটা অ্যাকচুয়ালি একটু অসুবিধাই হচ্ছিল তোমার, কারণ ক্যালকুলেশন তো ভাবে মুখে বোঝানো যায় না। আমি যেটা মেনলি বলতে চাইছিলাম তোমার যখন একটা কোশ্চেন পাবে তা অ্যাকচুয়ালি র্যান্ডম এক্সপেরিমেন্ট কি সেটা বোঝার চেষ্টা করো, এবং করসপন্ডিং যে র্যান্ডম ভেরিয়েবলটা আছে সেটা কোন ডিস্ট্রিবিউশনকে স্যাটিসফাই করছে। যখনই তুমি ওটা ধরতে পারবে তখনই তুমি তাই প্যারামিটারগুলোও ধরতে পারবে, অ্যাকচুয়ালি প্যারামিটারগুলো কি কি, আর তারপর জাস্ট ওই তাতে প্রবাবিলিটি ডেনসিটি ফাংশন হোক বা প্রবাবিলিটি মাস ফাংশন হোক সেখানে পুট করে দেবে। ঠিক আছে, আজ এ পর্যন্ত।